Hi, today we're going to be looking at the ln function and do derivatives with that. So the rules here in your textbook, and I'll just highlight them for you here. If you have ln of a function, do the derivative, it's 1 over x. If you have ln of a function, it's simply the function down the bottom line and the derivative of that function on the top line. Now we're going to incorporate this in terms of using the product rule, quotient rule and all those sort of things. Function of a function, so you'll get the idea of what we're doing. Just lost the page. So we come down here, we've just got a couple of examples to go through with that. So if we got this one over here, so our dy dx, well, that is going to be equal to, what's going on over here? Right, that's better. That's simply going to be it's a function, isn't it? Right, so in this particular case, our function is 5x, and then the derivative of that is going to be simply 5. So that's going to give you an answer of 1 over x. Okay. If we did this one over here, dy dx, alright, that's going to be equal to, well, the function we don't think about, just write down the bottom line, 3x squared take 5x, and then we just derive it on the top line. So that's going to be 6x take 5. Finished, done. If we've got this function here, number 3, you can see we've got two different functions here, so we're going to have to use the product rule with that. Alright, so dy dx, hopefully you're at the point where you can just do this in your head. Alright, so what we previously learned about that would be, it's e to the 2x times by the power of that, or the derivative of that, so that would be 2, so that's going to be 2e to the 2x, derivative of f dashed, times by g, which is ln of 2x, and then what I do over here is I add my f function, e to the 2x, I derive this function here, that's going to be 2x all over 2. Okay, so f of x and then f dashed of x. Now I can simplify that if I want to, but essentially I've just shown you the derivative. With that, now over here, if we're going to do our, for number 4, if we're going to use the quotient rule. Right, so again our f function's at the top here, our g function's there, so that's simply going to be 2e to the 5x times by 5, times that by our g function, ln of x squared plus 1. And then we have to take away 2e to the 5x, and then we have to derive that. So that's going to be x squared plus 1 on the bottom line, and then the top line is going to have 2x. Then that's all going to be over the g function, ln of x squared plus 1, and we have to just square that. That's my derivative. Okay, so you just follow the rules step by step by step, and then that sort of gets you through what you have to do. Alright, so good luck with those questions in 5C. There's a whole range of different ones for you to try. I mean, the key thing for these sort of questions is you need to identify that as being two separate functions. Here, you don't have two separate functions, you just simply have one function. Right? For this question here, you've got two functions. Alright? Obviously two functions there, two functions there. Alright, so you get the idea? Some do have two functions, some don't. I should just show you one with a using a power of, like a function of a function one. Let's do one very quickly for you. So if I was doing something like, let's do example 5, if I have y is equal to to the power of 5, okay, then I'm going to use my function of a function rule. Right, so I'm going to simply say dy dx is equal to 5 bracket 4, I better write it in, x squared, and then I simply times that by the derivative of that, and that's simply going to be x squared on the bottom line and 2x on the top line. Alright, So it is as simple as that. These things I think are really, really easy for you to do. Just practice will make you really good at it. Alright, so good luck with that. Make sure you catch up with me if you need some help.